Okay, if A, B, C, and D are four smallest positive angles in ascending order, so I can safely assume then, right, that angle A will be somewhere around here in the first quadrant. Okay, so I don't know, it might be smaller than that, it might be a little bit bigger than that, depending on what they're talking about further in the question. So it says in ascending order of magnitude, which have their signs, so meaning a sine of A is equal to a sine of B, which is equal to sine of C, which is equal to sine of D. Okay, they're all equal to K. Now the only way this is possible is if this arm here, right, it forms relative acute angles here. Okay, so the second angle B must be here. Okay, and the third one must be, since it has to equal, it must be again in the first quadrant, but this time what it is that it's rotating full 360 and then a little bit A more. So you get the idea here. Essentially what I'm saying is B is equal to 180 degrees minus A, and C must be 360, so 360 plus A, and D must be a 540, right? So 360 plus 180, and then another subtract A. Okay, so what I'm saying with D is this: you go all the way around, and then go back, go another 180, and then subtract by A. So that's what B, C, D is. That's what they're talking about here. That's the only way the sine A, sine B, sine C, and sine D will all equal to the same value, where this K value is positive. So the K value being positive just means that the sine, the angle that we're talking about, is either in the first or second quadrant. So I assume the sine A was in the first quadrant because they said the smallest positive angles, right? So if it was in second quadrant, it'll be bigger. Okay, so I just wrote down the equation again. I'm going to try to show that this is equal to 4K. So sine of A, I can just change it with K. Now B, I can replace with 180 minus A. So we get a 180 minus A over 2, which is going to turn into a 90, right? A 90 minus A over 2. Plus 2 cosine of C over 2. So C I can also replace with 360 plus A. 360 plus A over 2. Now that's going to turn into 180, right? Plus A over 2. Okay, and then lastly, sine of D over 2. I can replace that with 540 minus A over 2, which is going to be replaced with 275, right? Sorry, I mean like 270 minus A over 2. So 270 minus A over 2. Okay. So we know something about when it's 90 minus some angle, right? This is called cofunctional identities, right? So if it's 90 minus A over 2, it's going to actually equal to the cosine of A over 2. So this is a supplementary relative angle. So it's going to stay as a cosine, A over 2. However, because this represents an angle in the third quadrant, if A was an acute angle, this is going to be negative instead. Okay, so it's the cast rule. And lastly, sine of 270 minus A over 2. This is also in the third quadrant, so it's also going to be negative for sine. And it's also going to change to cosine of A over 2. So, I mean, I think I always find that the cofunction identity students have a hard time recalling what they learned. So we have, like sine 90 minus theta is equal to a cosine of theta, right? Or if it was like a cosine 90 plus theta, I hope you remember these things. It's going to be minus sine of theta because this represents second quadrant. And cofunction identities always change into their cofunction identity. So sine is actually a complement ratio of sine. Okay, so recall, go back to the lesson on like the cast or why these are the way they are, and then you should be able to easily go from this step to this step. It's too much for me to do an entire lecture on it first, just to go to take this one step. Okay, so now you can see that we have 3 of cosine of A over 2, and we have a minus 2 and a minus 1 here, so they will all add up to nothing. And we've just proven that this whole thing is equal to 4k.